So, hi everyone, and welcome to this session on GUI. My name is Susanne, and I'm a PhD student at the LMU Munich. And I'm really happy to host this session today. And I'm looking forward to get some insights into GUIs. I think this is just a great addition to the panel discussion that was on yesterday on GUIs. Before I start, just some organizational things. So please write your questions in the Q&A window you can find on the right. So not the chat, but the Q&A window. And I hope we have enough time to answer them. Otherwise, I'm sure the speakers will be happy to answer them asynchronously in the Q&A section. So let me start with the first speaker, which is Ross Durkhuizing. He's principal biostatistician at the Division of Biomedical Statistics and Informatics at Mayo Clinic in Minnesota. And he will talk about the transition of the Mayo Clinic from a commercial software to Blue Sky Statistics. So, yes, the stage is yours.
All right. All right. Can you see my screen okay?
Yes.
Okay. So thank you for the introduction. We're going to be talking about what the Mayo Clinic has done over the last couple of years, transitioning from traditional commercial software to R-based GUI Blue Sky Statistics in our large academic medical center. So why do we need easy software? The vast majority of research at our institution aren't programmers, and they really don't have a desire to program or don't have time to learn. But yet the researchers want to be independent, and it helps prevent overload of our biostatistics department. And we think providing and supporting the use of good software is essential for clinical and translational science goals and education goals here. So what were the forces at play into this decision? We had a dramatic increased license cost of our commercial software product, and that we've used for over 2 decades, and that's JUMP. And that, if you aren't familiar with it, that's a SAS Institute product. In the graduate school, we had students' desire over the years to have transferable software knowledge when they leave Mayo Clinic. You know, basically, a lot of them are saying, well, why are you teaching us JUMP? You know, they see R all the time in publications and things like that. You know, show us R. And there's a push to support more diverse analysis tasks in our statistical consulting center, of which I help staff. So back in fall of 2018, we actually reviewed a ton of different software packages. We thought, well, can we just take something off the shelf? So we put JUMP up against the common ones like SPSS and Stata, but also some other ones that are probably less familiar to you, like EpiInfo and MedCalc, Systat, and the like. We did do one R GUI, and that was R Commander, actually EasyR, which is just R Commander with some clinical analysis extensions to it. And we've had a rubric for about 20 years, and that rubric consists of, do the data sets live within the firewall? Is it available on Macs? How well does it handle data wrangling tasks? Because that's a very important piece of doing real research. How well does it do analysis tracking for reproducible research, or does it do it at all? What's the breadth of the statistical analytic capability? And what can it produce publication quality figures? And after this exercise, JUMP won pretty handily. Stata was actually a distant second, but it really just bought JUMP more time at Mayo. We knew it wasn't a long-term solution, so we were kind of stuck. And we thought, well, we know about EasyR, R Commander. Are there other R-based GUIs out there that we don't know about? And we weren't familiar with any of them, but we found rforstats.com, run by Bob Minchin, and he's got wonderful reviews on that website. And so after reading the reviews, we wanted to look at 3 of them, and those were Blue Sky Statistics, Jamovi, and JASP. And Blue Sky was ultimately chosen based on its feature set, the ability to add features ourselves, because you can add new dialogues to it, and a willingness of the Blue Sky company to partner with us to meet the needs of our researchers and learners. And in case you're wondering, Blue Sky approximately equals JUMP in our scoring rubric. So in the summer of 2019, we started the transition process. We did a phased rollout. We've got multiple groups of people that we need to move out of their license. So we started with the graduate school. They're kind of low-hanging fruit. That was summer of 2020, a little bit delayed by COVID. But we have 2 different JUMP licenses, and we transitioned one group in the fall of 2020 and the next group in the fall of 2021. And those groups are basically the least users to the most users that we have. And we reappropriated the funding from that phased rollout to support our transition efforts. And we started in that summer of 2019. We added a whole bunch of new dialogues to Blue Sky. We absolutely needed some features that they did not have using their wonderful dialogue designer tool. And to date, Mayo Clinic has created or contributed to more than 40 menu dialogues in their system. So what did we do? We basically implemented a lot of the survival package. Many of you are familiar with that. So we implemented, Kaplan-Meier curves, competing risks, estimate extensions, of course, Cox proportional hazards models, and in the kind of simple case, but also we did some other flavors like stratified Cox models, fine gray, and we dipped our toes in the time-dependent covariate universe, at least in a very small use case, but we're going to probably add that over the future months. We added some tools for large-scale data and model summaries. This is implemented our Arsenal package, which is also a Mayo-developed package. So that's available on CRAN. So we encourage you to go check that out. It basically can do manuscript table ones with p-values very easily. It can do frequency tables in list format, kind of like SAS proc freq with the list option. It can compare data sets, kind of like SAS proc compare, and it can table multiple model fits really easily. So we implemented 3 of these initially. Kind of these are the 3 big model classes that we need: linear, logistic, and Cox models. We added some tools for agreement and reliability, kind of like Bland-Altman, different flavors of kappa statistics, concordance and interclass correlation coefficients, and we did some diagnostic testing tools. Even though Blue Sky had a ton of data wrangling already in it, we added some things that over time I thought were good ideas. Like we've got ones that go take values for date variables and check whether they're out of order or not. Those values are out of order. We can find duplicates, select first or last observation within groups, do lags and leads. And we, among other things, we implemented something called Explore Dataset, which basically uses the summary tools R package, which I really like. We did some other miscellaneous things. We added some things like conditional logistic regression, quantile regression, forest plots from multiple different model fits, and we added some features to some of their existing dialogues. So one of the things we had to do, we had to translate the existing researcher education material that we had, and we've had this stuff for 20 years, so we had to get that out of JMP and into Blue Sky. These things assume no prior knowledge of statistics or software packages at all. And these kind of satisfy the 80-20 rule, that if you have this set of 10 things in your toolkit, you can do about 80 to 90% of what you would need to do in a typical research project at the Mayo Clinic. And these written handouts, they have screenshots, accompanying videos, and example data sets. And each of these lives by themselves. So if a student or a researcher is new to the topic and their mentor says, hey, you need to do survival analysis for this project, they can go right to it and grab that information and get started. We implemented some road shows, so we kind of around the clinic internally. These were unplanned and not advertised, but a ton of research groups asked us about doing them. They basically wanted a broad overview, anywhere between 10 and 60 minutes, and I tailored it based on the time I had allotted to me. I did about 20 of these in total, and some of these were extended to our external research partners, different universities and things like that. About halfway through, we decided to reimagine them. We had a particularly vocal research group internally that was less enthusiastic about leaving JMP behind, and said, instead of assuming no background, I basically showed their seasoned researchers how to do what they do now better or more efficiently, because JMP is now the engine, R is now the engine. So, and I showed them new things that they were unable to do before that were related to the kinds of studies that they do. And it really was a quiet comparison to JMP without me actually saying the word. And this really became the standard presentation going forward. And so I showed them how to do things like this. This is the standard table 1. You can see in almost every manuscript. This is really easy to do. I showed them how to do things like, I know this is really simple, but putting p-values on a plot or the number at risk on a Kaplan-Meier curve like that, those are the kinds of things that JMP can't do. People used to do those manually, kind of in superimposing text boxes in Photoshop and things like that. And they can just click a button now. I showed them how to make different model fits. Like this one cycles through a bunch of variables in a Cox model setting where you're adjusting for gender in each, or sex in each model. And these tables are totally customizable. This is an example of a forest plot I showed them how to do. Again, a couple clicks and this just pops out. Through this process, we had to be very flexible in how we educated people. In my mind, there's kind of a balance between everything you should know about a software package versus the minimum you need to transition if you're unfamiliar with it. And it was kind of hard to anticipate all those needs up front. But so one of the things we did was we created a FAQ, which we'd never had before, for common issues that people were having. We created some jump to blue sky cheat sheets that basically had a table of, this is the task you want to do. How did you do it in jump before? How you do it in blue sky now in a very basic level. We have 2 of those, how to do a basic analysis task and then translating the variable types. And we did a handout for what I call dates demystified because people were having problems with dates. And through all of that, some really needed to be shown live even further, and they weren't caught by the road shows. So in the fall of 2021, we actually developed 2 workshops. They were taught 4 times each at different times of the day, different days of the week to try to catch these clinical researchers when they're not actually seeing patients. So we implemented 2 of these. They were introduction to clinical analysis, and then one was data manipulation, kind of the 2 major pieces that you would need. So if you had 2 hours to spend trying to figure out the blue sky software, these is where I send people now. So these are really extensions of the revised roadshow. Of course, we had handouts, practice data sets. They were all recorded. We transcribed the Q&A. It was all posted so the learners could go back and refer to it later. We also found, one-on-one consults through our consulting center was also very important because sometimes that human-to-human, one-to-one, one-on-one interaction, getting someone over the hump to doing something new was really important. We had a concept of content creation control. We created an internal one-stop shop website for all blue sky education. And this is really crucial to us. It might sound trivial, it's like, it's just a website, right? Well, we never really had that before. We had kind of processes in place that were a little bit onerous. So our video creation tools and our website now use open platforms separate from our standard production processes so we can get these to learners quicker. So it takes minutes instead of months. We try to control the messaging. So we sent multiple periodic emails to the users touting, why we were switching. Basically, there was a gigantic cost savings, what the software process was like, the advantages of Blue Sky now that it's powerful, resource links, how to transition, and the Department of where all biostatisticians sit was sent their own versions with wording in case they were approached. We basically wanted that consistent message no matter who they talked to. We had to do some IT setup. We have a much more direct process to get Blue Sky versions installed on our servers. That turnaround time is now hours to days instead of it being attached to a license renewal that's very infrequent. We set up separate inboxes for IT-related questions. We had people that were staffed to handle them and separate from our statistical consulting center. So they can handle things like installation questions and bulk jump to Excel CSV dataset conversions. Some investigators had hundreds to thousands of data sets that they needed converted. So we developed some SaaS tools on the back end to have that work no matter where they lived on Mayo's server system. We kind of did a train the trainer. The graduate school curriculum was all changed over to use Blue Sky. All our consulting center statisticians were trained to use Blue Sky, and they were given funding and protected time to do it. Some observations through this process. We actually saw a bunch of website hits and download spikes that coincide with every large touch point we made, whether it was an email reminder, a roadshow, a workshop. And unfortunately, when their jump licenses finally expired, there was another hit to those spikes. So basically the message is you can't do this overnight. The more contact you have with people, the better. We found that all content gets used. The multimodal types of education are helpful. And again, one-on-one can really help ease their fears and help them leverage what they already know to doing something new. And we have a lot of examples now of people saying, we can do that kind of thing now that we couldn't before. And yeah, we can. And researchers sometimes ask us, can you build this for us? And I say, yeah, we can do that too. We have examples of students, researchers, and statisticians modifying the Blue Sky generated R code. And that head start kind of makes the R coding less scary. One thing that I'd like to say is you should really know your organization's processes and barriers and make them shorter and minimize them, kind of get out of your own way, think outside the box to make stuff happen. And this process takes a lot of teamwork, and you need advocates and champions at all administration levels, especially to navigate potential difficult conversations that you might have. I really believe at the end of this is really worth it. We're kind of on the downward slope of that trend of people transitioning. And I have nothing but the highest respect to say of the Blue Sky development team and them working with us. I really like that software a lot, and we just encourage you to check it out. So where are we going? There's a new Blue Sky version 10 that you're about to hear about. So we need to port all our dialogues over to that software. We are going to implement hopefully some advanced survival techniques. We need kind of start, stop, time, data set builder tools. So we can handle things like recurrent events, more general time-dependent covariate things, maybe go into multi-state models. I like to do things with propensity scores and subject matching. Those are kind of common around here. And we're going to modify some of the dialogues we have. We've learned which kind of things which work better versus others. I'd like to develop more education, like short form videos and something that you might think is an oxymoron, but reproducibility in a GUI environment with R underpinning it, that is now possible. So that is everything that I have.
Great, and right on time. Thank you.
Yep.
Thank you very much for this really interesting presentation. And there's already a question on the Q&A section, so let me read that out. So Dale Human asks if that's Blue Sky 1 on your rubric, what were some key factors that beat JASP or Jamovi? I've just learned of all three of these, so just asking for learning, no bias here.
Yep, they're all good tools, but what separated Blue Sky, I think, was the ease of getting a dialogue into the tool and the data wrangling capabilities that it already had. So if you're a statistician, you know that 80% of your time is spent doing data cleaning, and that is by far the most important thing. So that was the driver for us.
Great. I think there are not other questions. So if anything comes up in the audience, just post them in the Q&A session, and also refer to Ross so he can answer your questions in the Q&A session asynchronously. Great. Thank you again.
Thank you.
So the next one is now Sanjay Kumar, who's the CEO and founder of Blue Sky Statistics. So right now we saw the application side, and now we get some insights on the new architecture and the new features of the 2022 release of Blue Sky Statistics. The stage is yours.
Thank you, Susan. Thanks a lot, Ross. That was a wonderful presentation, and it has been a great partnership, great journey working with Ross and his team, as Ross mentioned. So we learned a ton along the process, that which in turn helps our community because those all gets back into our product, our architecture. So thank you, Ross and his team again. So let me share my screen. All right, can you see my screen, Susan?
Yes, now. Thank
you.
Okay,
perfect. So anyway, let me get started without losing further time. So good afternoon, good evening, and maybe it's good morning for some of you who are joining from Asia or Asia Pacific locations. So thank you so much. So I am Sanjay Kumar, as Sujan said, the CEO and the co-founder of Blue Sky Statistics. Today, I thought I'll take the opportunity to take you through that some of you are probably aware of it. We recently, earlier this year, launched Blue Sky version 10, which is completely re-architected. So let me walk you through what drove us behind that huge time and effort that you spent. And at the end of the day, obviously, the architecture is just architecture, but it has to benefit you as our Blue Sky users. So let's go through that. So with that, I'm going to give you a quick overview if some of you are not familiar with Blue Sky Statistics. Of course, you heard some of them from Ross, and walk you through what drove us to the new architecture. And then at the end, I also want to give you a quick glimpse to the roadmap. So with the Blue Sky Statistics, as you just heard from Ross, that it's been designed for people who, first of all, foremost, is that that I'm an analyst, I do not know anything about programming, I don't want to code, so I just have my data sets, I have my analysis, I have to produce my results and collaborate with my team. So that's what it was designed for from one side of the audience, which is a very rich UI output. And then at the same time, we also have hands-on programmers, as I said, oh, this is based on R, why not I add few things there? You know, I know how to do R programming. So we also brought in the very powerful R IDE code editor, so that you could also roll up your slips and write your code if that's what you choose to do so. So many of our users who are transitioned from other commercial software like SAS or SPSS or JUMP that you heard, and many of them, we get this comment very routinely that your software is very easy to use. So that's what we take pride in this. And then and we wanted to make sure that the software is flexible and extensible. Otherwise, you know, it's R. So our community has 2 million users constantly contributing new algorithm, new functionality. So your application has to cater to that. Otherwise, you'll be waiting for us, you know, 6 months, 1 year that we add 1 or 2 functions, just like the way the commercial software do their release cycle. That is not what the purpose of this. You want it to be in sync and catch up with our innovation, so that your application is not the bottleneck. It can expose anything that you wanted to expose to your organizations, or putting back into the community, creating new UI to expose those functionality. Like our community, our users, last count, it's about 112 countries, more than thousands of organizations using us. So that's university, commercial organizations, government, non-government, research organizations. So our team also mirrors the same way. Our development team is also global, and our headquarters is in Chicago. So with that, you probably guessed this thing, what's our mission is. Our mission is to make sure that we offer at the best user experience and a very rich functionality to the non-programmer, the analyst audience, which is basically the point and click. So whether it's you're doing the beginners as a student or a teacher, teaching frequency and descriptive analysis, or you are doing the very advanced things that the Ross kind of example and given the talk about some of those. But at the same time, also we cater to our programmers. If you wanted to extend the functionality or transport your code back and forth between our studio and us to test your code before you plug that back in. And we wanted to continue to provide the framework, as I said, to the user community. And lastly, it's very important for us that we take it very seriously, that we wanted to make sure that we level the playing fields for every user. We believe that everybody around the world, irrespective of their affordability or economic background, they should have access to the data science and data analysis, because that's where that people can use that, find answers, find truth, and help their community, help their country. So we'll stay true to that for the life of the Blue Sky Statistics. So with that, what's the motivation behind the new architecture? So new architecture, the primary thing was that the original architecture was all Windows based, and it served its purpose when it was designed originally. But now we started to seeing that more and more adoption of the Apple and the Mac technology, especially in the universities. You yourself has seen that how the transition has happened. So all the university kids now carry the MacBook laptops. So with that, it really became a hindrance for us with the old architecture, not able to support the Mac. The second thing also, that the original UI was designed for software like SPSS and other for those users to transition. But now, as people got exposed to a lot of the web-based application, nothing to do with the statistical analysis, but in general in their life, whenever they're using any other software with the web-based, so they expect to see the similar usability and the look and feel. So we needed to really transition into a more web look and feel going forward. And finally, we also need to lay a foundation so that it can sustain for the next 5 to 6 years, that we can continue to add more the innovation and the speed of delivery of functionality to our user community. So those are the things that drove us. So for that, we debated quite a few things. We looked around a lot of the different technology to see what exactly we should invest on, because these are the things you're making investment for next 5 to 6 years, if not longer. So it's a very serious decision for us. And we decided to choose Electron, which is open source. You could take a look at it. And the benefits about the Electron was that this is a cross-platform, means it can support all the different platforms with a single code base. And it brings all the web technology within it, JavaScript, HTML, CSS, all of those things with a Google's Chrome browser engine built into it. So essentially, you get the benefit of anything that you wanted to do with the web, look and feel wise. But at the same time, we didn't want it to lose the richness of a desktop or the install application that come with it. So we decided not to go the full web route, but gone into a all web technology, but still a desktop application. And the beauty of that was this Electron that brought that thing together. And we felt pretty comfortable at the end of the day making that decision, because all the important software that you see, the Slack, Microsoft Team, GitHub Desktop, WhatsApp, they all built on Electron technology. So now we stretch that. So Electron technology is powering our front end. And then we introduced the Python as our middle layer to connect with the R. And that's now, if you look at it, it's all open source, it's all cross-platform support. So nothing proprietary to any particular platform. And on top of that, one other futuristic thing that we have, now that we introduce Python in our mix, in future, it also gives us the opportunity to tap into the Python's own claim and fame about the machine learning algorithms and packages to complement with the art that we already offer. So that's where you're pretty excited. And as you see, I just put a little comment there. It took a significant effort for our team to really get to where this is, but we are very proud of that we are able to pull it through, and we made the release earlier this year. So with that, obviously the question is the so what, right? The so what question. Okay, you invested so much of time and effort, you created all of this thing, those all sound nice, but what is it in for me as a user? How does it benefit? So the benefit, as I said, the purpose of that whole new architecture was that we wanted to transition into a modern web look and feel, and with the desktop heavy user experience at the same time. So now you see our UI look like it's a web, and it still has all these menus and drop downs and other things like a desktop application. And you're still able to open multiple data sets, and you have multiple output panel to separate your outputs. Then you have the production ready output table that you could copy paste to your journal. And also we have now offered that you could reorder or delete your portion of the analysis before you save the entire analysis and export this thing out. So all this flexibility of a UI that you have. And then the second bullet point was, it's about that because now it's all web interface for us underneath, we are able to take the cable extra package from R, that which produces the table formatting in the HTML. So we are readily was able to leverage that because of our HTML-based UI technology now. So with that, now in our settings, you could go ahead and choose any of the cable supported 6 or 7 different table formats they had. All of them are now available at your disposal for you to see how the table look and feel changes immediately with a point and click. And in addition, also we introduced the LaTeX, and that's also very important because you can now get the same table in a LaTeX code that you could cut and paste if you're writing a journal or publications. So with that, the next one is that your reproducibility and the teach with learn. So we have now a whole powerful R editor that you see on the left-hand side of our panel. Now you could cut and paste, copy, step through it, transport code between R Studio and us. Then also we introduced the tidyverse for most of our common statistic function for you to teach or learn. And that's what's very important. We'll continue to add more. Now it's like frequency, descriptives, t-test, linear regression. They are all now a tidyverse syntax that you could click and learn how to use R if you wanted to learn R directly behind our analysis. And the reproducibility, so you could now export things out for sharing, rerun the whole thing again, or you export our whole analysis into an R Markdown. Then you could take that and run in another R Markdown environment like our Studio to rerun and reproduce your analysis. So with the extensibility that we just talked about, we kind of tried our own dog food. So we use the new extensibility, and then it's showing you here that we are very quickly able to create that we are going to be launching very soon the design of experiments and the Six Sigma and the quality chart, the quality control charts, all these new modules that we build ourselves just to test out this new the new framework of extensibility to add new dialogues, because that's very crucial for us to continue that path, as Ross mentioned, because everybody has their own needs and R has so much of innovation. You don't want to be bottlenecked by us, and all those things will be released in a week or so. So with that, just a quick roadmap to show you where you are going. As I said, this the whole new functionality to expand into the quality department or the manufacturing and others, that people who absolutely need Six Sigma. And again, just like Jump and others, very expensive softwares out there that you have to pay for. Now you'll be able to use as for free to do your Six Sigma and the quality control, design of experiments. And this is also proven our framework to make sure that we are able to add new functionality and new UI very quickly using the tool set that we are about to release. So with the extensibility, we are going to go ahead and do further work on that. We are planning to create a marketplace on our public website so that people can contribute and other people can absorb them as and when they need it. Or the contributor may decide that I put so much of effort, I want to charge a fee or a donation. So we are going to provide those models that you contribute back, you want people to use it for free, or you want to charge them. So that way, the motivation is there for everybody to contribute for some contribution of money or just for free. And there is a whole big rock items that I put there for the statistical analysis functionality that you continue to improve. And you're going to see some of the discussions from next speakers, but others are coming up in the upcoming releases. And finally, for the general improvement of the reproducibility. So obviously right now you're able to run a set of analysis. You could export it out and load it back into or share with your colleague, rerun it, get the same results, or you take your code from us and run it into our studio with our markdown, get the same results. So those are all great that we already have it. Then also we are thinking about further, which is more about the reusability, more so than reproducibility, that, okay, you run the data set for, say, a survey for Chicago metro area. And the analysis, you wanted to take that and run for a data set for Detroit. So how do you take the same analysis, send it to your colleague? All they do is just swap the data set and map the column, and then you get the same the results for Detroit. So those are the some of the ideas we have, and we're collecting feedback now from our user to go for that. So that was our last slide. And let me pause here and see whether people have any questions. Susan?
Great. Thank you. You're also on time. So thank you very much for this really interesting talk. And there are a lot of Q&A questions.
Okay.
In the interest of time, we might not be able to answer all of them live, but I'm sure you will hand in your answers below the questions afterwards. So the first one is of Dale Human. He asks, does Blue Sky perform validation or provide validation packages for teams and that may use it in regulated industry, FDA, EU, MDR, etc.?
We haven't done anything ourselves to do the validation for FDA submissions and others, but I will be more than happy. So if you could reach out to us at this email address, introduce yourself, I'll be more than happy to understand what we could do. As you said, if something is available in our community, we could immediately expose that. So I'll be more than happy to work with you.
Great. There may be another question before we come to the next speaker, which is also interesting for me because I'm a Linux user. So Nathan Adams asks, does Blue Sky plan an edition for Linux?
Yeah, as I said that as I walked through the architecture, this architecture was designed to run on all three. So obviously in the Linux, the only thing we have to do is to find the time and some resources to test it. Otherwise, architecturally, there's nothing that we have to do to support it. It's just a pure the time and priority. So if you're willing to help us on that, I'll be more than happy to take your help on this. So please, again, send us an email. But the architecture is designed for that, to support all platforms.
Great. Good. So there are, I think, 4 questions left, or think one is an answer, kind of. So maybe, Mr. Kumar, you can have a look on them and answer
Sure.
them asynchronously. Great.
Sure. And then let me stop sharing then to hand over that to you.
Great.
Thanks, everybody.
Thanks to you. So the next speaker will be Stephen Miller, who is social and quantitative psychologist and associate professor of psychology at Rosalind Franklin University of Medicine and Science. On his interest is on multi-level modeling, and this is also the topic of his talk, namely multi-level modeling in the blue sky statistics environment, growth curves, daily diaries, and experience sampling.
Okay. Thank you. Let's see. Okay. Can you see my screen all right?
Yes, we do.
Okay, great. Thanks. Thank you all for coming to our panel today and to my talk specifically. So I'd like to spend a little time talking about multi-level modeling in the blue sky environment. So multi-level modeling goes by a whole bunch of names. It's known as linear mixed effects modeling, and for users of BASE-R, you know the Elmer package is commonly used, and it also gets called random effects regression. I know some people refer to it as HLM and a number of things. So I'm going to refer to it as multi-level modeling, but know that this terminology is interchangeable. The idea of multi-level modeling is that you don't have independent observations like is normally assumed in your statistical model. So rather, you have data where observations are nested. You have time points nested within an individual in the case of a growth curve model, or you could have students nested within a classroom in the traditional hierarchical linear model, or you could have brain slices nested within an animal. And so this works for all these different sorts of cases. So I'm going to focus on the growth curve where we have these time points that are nested within a person. And so when they talk about mixed modeling or mixed effects model, one of the key features is that we have both the fixed effects of things like time and the random effects, the variability that exists around the average and around the time point. And so I'm going to work through an example of a growth curve with you in the blue sky statistics environment. Specifically, this is an example that is commonly used in statistics textbooks on longitudinal data analysis. So this is the Potoff and Roy data set that is present in the Hedeker and Gibbons longitudinal data analysis book, among many others. And so in 1964, Potoff and Roy did a study looking at space between teeth. And so specifically what they did is looked at 16 boys and 11 girls. And the way that the dentists measure things is the distance between the pineal gland and the fissure on the side of the face. And as kids age, the space expands, and boys and girls have approximately the same space early on, but as they grow, the space changes at different rates. And so we can sort of see the interaction between the sex of the child and the spacing as a function of age. So in the data set, you can see that the data is in the long format. So we have an ID number. So the first child has 4 rows of data, the second child has 4 rows of data, the third child has 4 rows of data, and so on. And we have the age and the measurement and the gender in this data set. So this is in blue sky. At the end, if there's time, I'll actually run this for you, but I have screenshots right now. So I just specify that from the model fitting, I go to mixed models and I enter a model name, mixed model, and I will drag over the variables that I want into their appropriate places. So the measurement between is my dependent variable, and as is the case with traditional R syntax, if I use the asterisk, then I will get the so-called main effects of time and gender and the time by gender interaction. And so since it's in the long format, I will tell the computer that, tell Blue Sky that the ID number keeps track of how the data is nested. And then once I have the nesting unit specified, I can tell the computer a little bit about what sort of random effects I want. So as you see, I've put in intercept only, but then I put in the time effect as the variable that exhibits random variance. So there's a mismatch. Also, we support the random restricted maximum likelihood and full maximum likelihood estimation. And so because I've made this mismatch between the model that I've specified and what is in the box, you know, you have these different structures where you can specify a random intercept only, or a random slope only, or a random intercept and slope that are correlated, or random intercept and slope that are uncorrelated. It doesn't make a lot of sense to have a random slope if there's no variable that is involved with that that particular effect. So I get a warning message that is actually understandable by a user who is not necessarily a statistician or programmer. So for people who are scientists and are more focused on their subject matter, you know, unlike R, where you get messages that may be difficult to decipher, you'll have a message that will give you some guidance as to what you need to do. And so there's a host of options that are provided within our multi-level modeling features. You can get things like ICC that many researchers want, but have to calculate by hand in packages like SAS or SPSS or whatnot. You get plots, you get some diagnostics plots for how things are going, and you can get the interactions plotted for you and different sorts of post hocs. And so I'll demonstrate several of these. So when I run the model, it's great. We get the equation of the model that we've specified. So I've gone back and corrected my error. And so I get an equation about what random effects are going to be in the model, what fixed effects are in the model. And then I also get the parameters filled into the equation itself. So you can see exactly what's going on. You get the omnibus effects in the ANOVA table. And unlike a lot of programs, we also have some effect sizes for multi-level modeling. So specifically, we've used semi-partial R squared. You know, if this conference was in person, we might be on the campus of Vanderbilt University. And so there's a recent quantitative psychology graduate, Jason Wrights from Vanderbilt, who has a new package for an R squared for multi-level modeling that works really well. And we may be implementing that in the future. The code can be pasted with the click of a button. And so if one is familiar with the code and just wanted to sort of see it written out and tweak things a little bit, you could paste it. And you could, if you weren't familiar with the code and you wanted to learn it a little bit, this would be a great sort of training step for you to sort of see everything. So you can see the actual Elmer statement where measurement is predicted by time and gender. And we have the random effect time nested with an ID. So I won't bore you going through the code, but if you send me an email, I'll share these slides with you. And so we get effect sizes calculated for you. We get summary tables, and we'll print the scaled residuals, the random effects, and the fixed effects, so you know the parameter estimates. And we see that we have a significant effect of time, a non-significant effect of gender, and a time by gender interaction, which is what I described for you. And these are not options. These are the sort of the defaults that get provided to everyone. So we have the ICCs, correlation of fixed effects. We get means displayed, EM means, and differences between males and females. And we get some visualizations that are nice. So what is the effect of time for boys and for girls, and what are the differences between boys and girls, standard deviation below and a standard deviation above the mean of time. And then we also get the time trend estimated for females and the time trend estimated for males. And you can see that the slope is 0.7844 and steeper for the boys. We get some diagnostics. So when we look at the raw data and we see the estimated data, how well are we doing with our estimated model in terms of capturing the raw data? And what are the shapes of our residuals? So that's all provided in the options. We get several warnings like don't look at the main effects because you have an interaction in your model. So the user is free to do as they choose, but they are given some feedback that this may not be the most appropriate thing to look at. We get plots with the scatter of points around them, and so that summarizes the growth curve model and the features that are presented in the options currently. So we could also have a daily diary study. So this particular study is from Susan Tran, Carol Grakowski, myself, Brandon Reed, Mercer Coven, Joanna Buscemi, and Rachel Greenlee in 2020. And this was a daily diary study for 14 days amongst college students. And they wanted to know if hassles, if there were differences in daily hassles between men and women. And so if you think back to the multi-level modeling conceptualization, right, I have a very sort of similar setup, except rather than looking at systematic growth going on as a function of time, the systematicity of the growth is not an issue here. I'm just looking day by day, are there hassles? So they're not independent observations, they're still nested within person. And so it's kind of like a t-test, except we have the random variability due to person taken into account. So there were 255 people in these analyses. And so here's an example of the data set up, again, in the long format where I have many lines per person, 14 lines per person, one for each day. And so I can put in the between persons variable of sex, and I have the random intercept, and I see that there are significant differences, and specifically the group that is coded male is 4.5822 points less in their rating of daily hassles. So males on a daily basis have less report less stress than females. So we could also take an experience sampling study where they have many observations per day and not necessarily look at between person effects. And so there are some different models about emotion that are out there that are competing. So some people believe that negative affect and positive affect are opposite sides of the same coin. And other people say that you can experience mixed emotions where you have negative affect and positive affect simultaneously. So in this model, we have a level 1 predictor, but no level 2 predictors. And so our module can handle this just fine. So the positive and negative affect schedule, we're predicting positive affect from negative affect to see what's going on. So multiple times a day for 1,369 participants. And so sure enough, we have a significant effect of negative affect on positive affect. And as negative affect goes up, positive affect goes down by 0.10, but it goes down a very, very small amount, right? Our effect size is only 0.02, and so the researchers left to know a little bit about the scale, whether or not that 0.1044, that is the decrease, is actually meaningful or not. So in the future, we have other work going on with growth curves and multi-level models. So we've begin designing a structural equation modeling module for Blue Sky. We haven't begun implementing it yet, but we'll be able to handle growth curves using the Levon package. And so that's on the horizon. And so the latent variable growth curve approaches in the structural equation modeling environment are more flexible in terms of sort of covariant structures that are allowed and whatnot. They sometimes are a little harder to get to converge, but we'll be implementing that. And using the GLMMTMB package, we are also working on addressing different distributional structures that might exist. So as Sanjay pointed out in his last talk, we're working on the logistic case with the binary outcome, but there are numerous other outcomes. So we can deal with Poisson or zero inflated data. And so we'll be building that in the with the GLM-MTMB package. And additionally, you know, the random effects are the layered ware sorts of models, the G matrix in the equation that you see in the upper right, but the residual structure can also be modeled. And so GLM-MTMB models some of that residual structure in the R matrix. And so these are the currently available residual structures. And so we've been designing these features for an advanced multi-level modeling module in Blue Sky. And we've also started programming it, though we're a little ways away from it. So that's about all that I have, and I'd love to take any questions that anybody has.
Great, thank you so much. So currently I don't see anybody posting a question in the Q&A. Right, yeah, so have a look on the chat. Okay, so maybe I have a question. So it was just great to see the diverse application cases and also that, yeah, multi-level modeling is so powerful and it's how it is really comfortable done in the Blue Sky statistics. So I know like multi-level modeling more from the like linear mixed effects model term. So is there a reason to prefer one over the other?
No, not really. I mean, so psychologists often use the term multi-level modeling, and I'm a psychologist by training. Originally, even before SAS had Proc Mix, the education researchers called it hierarchical linear modeling, right? And they always use the multi-level notation when people like Tony Bright and Steve Rodenbush developed it. And so I'm used to seeing that multi-level framework, and even like the first textbook that I showed, the Hedeker book, Don Hedeker was originally not so fond of talking about it as multi-level, but as time's gone on, he's come around to the idea of sort of keep breaking things into levels to make it easy to keep track of things. So I just call it that because that's the sort of parameterization that I work with, but there's no reason to prefer one or the other.
Yeah, so it's just a thing of the background that somebody have. Great, thank you. Thanks again for your great talk. Sure. So now we come to the last one, which is by Christophe Genolini. He is professor and master of conference at Université Paris Nanterre La Défense, and he is president at R++. And this is why he will also talk about R++, which is an easy-to-use graphical R interface for medical doctors. So the stage is yours.
Do you hear me?
Yes, we hear you.
Okay, cool. So first, I'm sharing my screen, and
it's great that we have a visitor here.
Yes, some of you were present at User 29 in Toulouse. Maybe you don't remember me, but you probably remember some crazy guys who were walking all around with a baby carrier. That was me, and this was Ariane, my daughter. So here is the follow-up. My daughter is now 3 years old, and she still wants to see User. So thank you for the introduction. My name is Christophe Genolini, and I'm working with R for quite a long time. I love R, like many of you, many of us. I write some packages and write a book, but I have to admit that for people who do not use R on a daily basis, people who have a main job like medical doctor, or many people who have a main job and who use statistics as a side, R is difficult. So So we create a new graphical user interface for those people. I was working in the medical field, So I start with medical doctor, and I make something like 100 meeting with medical doctor, and I ask them first question that was, what is wrong with your current software? What takes you ages, whereas it was supposed to be simple? What do you never manage to do, what are your pain? I get mainly 5 answers to that. Oops. I get mainly 5 answers to that, which was reading the data. That's surprising, but many, and if you go on the forum, many people do not know how to read the data. Second pain point is cleaning the data. And I have to admit that in R, it's not that easy to clean the data. And that was the second major point. Third point is medical doctor know a lot of tests. Medical doctor know a lot of tests, and they never know which one to use. They know t-test, chi-square, ANOVA, but they never know which one to use.
Yeah. One question: are we supposed to see your slides?
No, I have no slides.
Okay, good. Then it's fine. Sorry for the interruption.
Fourth major problem is when they want to build some more complex model like rock curve or survival, it's very difficult to master the code. And last trouble they tell was to export the result. They compute, they do results, they do statistics, and after that to take them from R to their article, that sometimes that can be hard. So with them, we try to find some solution to this point, and from that we make R++. So now I'm going to share my screen. And now, do you see R++?
Yes, we do.
Okay, cool. Here is R++, here is the interface, and we solve the 5 points that I just tell. The first was the import of the data, so that's not very complex to make a graphical interface to open data. And what we add was a preview. You can set up all the parameters here. And if something goes wrong, for example, if you try to read a French file with American decimal separator, you will get that. And so it's quite easy to see what's wrong and that something is wrong. So you can try to change, and then you see that the file is in the correct shape, so you can read it. Then you open it, and there is the problem of cleaning data. First thing, we add some color, and the color gives you many information. It gives you the type of the data. We have orange for the binary variable, we have green for the numerical variable, we have blue for the factor. And here you can see that this variable, which is called shock septic, is supposed to be a binary. It's supposed to be only oui ou non, yes or no, but it's blue, so it's not binary, because binary are in orange. So you can see here there is a typing mistake. If we go a little further, here there is a blue variable, so it's supposed to be a factor, but you can see that it's number. So I want this to be a numerical variable, but it's blue, so there is something wrong. So only by having the color, you have already many information about cleaning data. And then we have graphical representation and summary representation, and then you have for all the variable, all the information you need. And statistician will see immediately that here, for example, there is abnormal value. This is size, and this is a children who is 12 meters high. That's obviously an abnormal value. So you can, at glance, see everything that is wrong in your data set. Since abnormal value is either the highest one or the smallest one, you can click here. It will sort the column by increasing side, second times by decreasing side. The abnormal value is here. You suppress it, and it corrects it in your data set. Here, I knew first there was a mistake because it's not a range, Now that I have the graphical display, I see there is 5 value. I ask for a zoom, and then I can see that it's only some coding problem. Some students write with capital letters, some does not, and one just write O instead of we. So to correct that, I will use a tool called the typer. He gives me the list of all the possible value, and I will merge the one who should be merged by just drag and drop. I take the O, I put it at the O, I take the we, I put it here, I take the no here, and I say it's logical. And it corrects my variable, and now it's arranged like it's supposed to be. Here, the blue same, I will ask him to put it in numeric. But if he first put it in blue, it has a reason. The reason is here. There was a typo. Instead of writing 50, someone write 50A. So he thinks it is a character string. So I can edit it, correct it. So he highlight it in red and put it in the top. I can edit it, correct it, and here is the variable corrected. So here are some things that we can do to clean data very fast and very easily. We can check all the data and see at a glance. Third question was statistical test. It's quite easy to know which statistical test you have to do, but it's easy when you know it. So there is some precise rule. You know it's easy. You have to check again. So we just taught to R++ the rule, and now we can say it can pick the test for us. So the first step of the statistical test is to select a variable, which will be the reference variable. So today I want to explore shock septic. I click on shock septic arrives here, and then everything I will do will be relative to shock septic. So here I have graphical display, here I have summary. I will get the graphical display of, for example, sex versus shock septic. Here is the two plots, and for shock septic versus numerical variable, I get the box plot. And then for the statistical test, I just click here and it compute all the statistical tests with shock septic. I mean, every statistician will agree between two binary variables, you have to do a chi-square or a Fisher exact test. And every statistician will agree between a binary and a numerical, you have to do a t-test and a Wilcoxon or a Wilcoxon test. So he will compute all the tests that are the basic tests. If people do not remember how to choose between t-test and Wilcoxon test, we put here an help. You click on the help. Oops. Wow. This is demo effect. Do you still hear me? Or is it my computer which is crashing?
Yes, we still see and hear you.
Okay. So this is my first demo with the English version. We already sell R++ in France for 2 years, and apparently the English version is not ready yet.
No worries, take your time.
Yeah, that's okay. So I was saying that in statistical test, I pick this, I make the graphical display, I make the test, and I don't know which test between t-test and or Wilcoxon. I ask the help, and it gives me the help. And it's not statistic, it's not a lecture about statistic, it's just what you need. So the parametric test is t-test. What are the application rules? And if you can't use t-test, then Wilcoxon test. To go further, so that was the second point. The third point about picking the correct test. Then we offer some basic model, like for example, survival curves. This is quite difficult because you have to pick some variable and you never know which one is where. So in R++, we have to select the variable in a specific order. And this is our mascot, rhinoceros with wings. We call Rinel, which will be ring wings in American. It gives us some tips about what you should do. So for making Cox model, you have first to take survival variable. So this is not the correct data for that. I will do it with the correct data. So this is the time variable. Then you have to take the censorship variable. And then you have to take the group variable if you want. And that's it. You have your log rank model. And if you want to add some adjustment variable, you have your rank model, you have your Cox model, you have the forest plot, and you have everything you need to publish your article. And for the last problem, which was interact with some other stuff, you can just take something like Word, and you can drag and drop from R++ to the other software. So I can take this graph and I put it in Word. I can also do the same with some table. Here I take the age and copy. I go to Word and make past. And this is already a real table with some cells and things like that. So it's very easy to shape it. And still inside R++, we have Graphical Editor. You can change whatever you want. You can change the police and the font, sorry. Well, to publish, probably not use this one. You can change color, everything with a graphical interface. And last but not least, we have a table 1 editor, which you just pick up the group variable first, and then you add all the variable you want in your table 1. You can here pick up some, if you want the mean or not the mean, the median, you can set up some parameters. And when you're ready, you copy the table, you go to Word, Excel, or any, and you pass your table directly here. So that's it. Suzanne, I did not see if you sent me the orange or the red cartoon yet.
No, everything is fine. Yeah, you still have around 2 minutes, I guess.
2 minutes. I think that's perfect. Okay, so that's the 5 main points that we have to answer. Behind this graphical user interface, there is R. So if you want some more advanced things, you can here use some R. There is a console and there is a station. So you can write your R command here. But R++ is not designed for that. R++ is really for people who do not use R. If you want, you can have here the code that is used for the. I mean, if I remove this value, then in the code I will see that. Here the line that I just removed. So this is R++. Last point, I think I show you pretty much everything in R++. Well, not all of it. There is some things like adding column. For example, I will add a column here. I want to cut this column in 3 classes. I will just say that I want to divide age in 3 classes, and it will cut age in 3 classes. So I mean, there is some other tools, but there is no forecast. There is no structural equation, all this kind of thing, because we want to focus only on the tools that are used by medical doctor. The interface is very simple. I mean, if you don't remember, you use R++. Then you don't use it during 6 months, and you remember that it was possible to make some tests. There is no submenu, nothing hidden. There is only 6 buttons to try. And we want to keep it that way, very simple. So you cannot make some advanced analysis like mixed model effect. You can only do the basic, and that makes sure that that's how we make sure that it will stay very easy to use, even for non-statistician people. That's it. Thank you for
Great. Thank you so much for the tour. This seems to make data analysis really playful and easy. And I think it's really nicely and detailedly designed.
Playful is a word that comes very often when we ask some feedback about the user. Most of them say playful.
Yeah, I think then it makes more fun, I guess. So maybe one question for the user interviews and so on. So how long did this whole process take? Like, I could assume you need a really large team to do all these feedback rounds and so on.
So first, I tried to make a free software. When I was a teacher at university, during 3 years, I tried to raise money and to make a free software. That was before 2016. That was before 2016. And I failed, so I start to build my company, and the money was much easier to fund there. So I started in 2016, 6 years ago, almost day for day, because it was on the 24th of June that I start. So tomorrow will be our 6th anniversary.
Nice. Yeah. So there are 2 questions that came up in the Q&A. So maybe, yeah, we still have 2 minutes time. So let's see if we can answer both questions. So the first one is, your website talks about parallel commuting. What does your software use for that? The PDDR package?
So we switch. Basically, we want to make parallel computing. We want to deal with big data. And I never managed to find a single person very interested by big data. I mean, who will be ready to pay for it. So we do not use any R packages. We use, we program the graphical card ourselves in CUDA. And after 2 years of not selling anything and not finding anyone interested in big data, we just stop, because I mean, we have a joke in French. We say that big data, it's like sex for teenager. Everyone speaks about it, but no one ever does it. And for me, it was this. I never managed to find someone who was ready to pay for it. Whereas we have some crazy performance. We were something like, we were IBM partner, and on the PowerPC, we were 80,000 times faster than R. So it was crazy performances. But so no one wants to pay for that, so we give up. And now we focus on a user-computer friendly interface.
I see. Yeah. So, we have only 15 seconds left. Yeah, maybe I ask last one. Sorry if I missed it, but does the mascot also warn the user about issues related to multiple testing when calculating many p-values by one click?
So in the next version, we will have a button in which you can ask for the multiple tests, and you will say, I want 5 multiple tests, and then the significance will be lower according to the number of p-values. Meaning that if you want 2 tests, then you will not have the 1 star if the p-value is lower than 5%. You will have 1 star if the p-value is lower than, I can compute it by head, but that's the idea. That's the idea.
Okay, great. So thanks again to you and all the other speakers. It was a pleasure to host this session. Also, greetings to Marianne. And I wish you all a nice rest of the day and a nice rest of the user.
Thank you.
Thank you very much.
Yeah.
Thanks, Susan, for coordinating it. Thank you.
Thank you.
Bye.
Bye.